Good morning, students. Today we will discuss about the variation of physical properties in different periods and groups. Physical properties like atomic size, ionization, enthalpy, we will see. Okay. So first one is the atomic size. First of all, we should know that what is the atomic size. What happened? First of all, what is the atomic size? Atomic size is the distance between the center of the nucleus of an atom and its outermost shell. Means, what is the students? Atomic size means, first of all, you should know about the atomic structure. In atom, there is nucleus in center which has positive charge on it because there are protons and neutrons. Protons and neutrons are present in nucleus. And around the nucleus in different energy levels electron revolve. So what do you mean by the atomic size and atomic radius? Atomic size is the distance between center of the nucleus. Let us consider this is the center of this nucleus and this one is the outermost shell. So this distance between the center of nucleus and outermost shell is known as the atomic radius or atomic size. If we have any other atom which have more than one shell, then again here atomic radius is distance between center of nucleus and outermost shell. Yes, atomic size is the distance between center of nucleus and outermost shell. Let us consider this is the nucleus center and this one is the outermost shell. So this distance is known as the atomic radius. But student, if a molecule is present there, then what do you mean by the atomic radius? If a molecule like H2, if we have, then what will be the atomic radius for this? So it is the half the distance between two adjacent atoms of the same element in a molecule. So here in a molecule there are two atoms. One is hydrogen atom and second one is also hydrogen atom. So let us consider it is the center of this atom and this is the center of this. So if we connect both of these, it is known as the bond length. It is known as the bond length. bond length. It is the distance between nuclei of two adjacent atoms. And half of this bond length is known as the atomic radius. For example, just we are considering that if this length is 48, then half of this is 1 by 2 into 48. So half of 48 is 24. Okay. So here, what will be the atomic radius? Atomic radius will be the 24. So if we have molecule, then atomic radius is the half of the distance between two adjacent atom of the same element in a molecule. And we measure the atomic radius in picometer. Picometer, 1 picometer is equal to 10 raised to power minus 12 meter. So atomic radius is expressed in picometer. It is clear to you what is the atomic radius. Atomic radius is the distance between center of nucleus and outermost shell of the nucleus. And if we have a molecule, then what is the atomic radius? Then atomic radius is half of the distance between the nuclei of two adjacent atoms of same element. It is clear to you? Yes. In general, the atomic radius decreases as we move from left to right in a period, and it increases when we go down a group. Means, student, it is difficult to measure atomic radius of the individual atom. So we will see the trend in group and period for the atomic size. Okay, so generally if we move left to right, left to right means if we move in a period, then atomic radius decreases. Atomic radius, or we can say atomic size, decreases. And when we move top to bottom, means in a group, generally atomic size increases. Atomic size increases. Why does it take place? Now we will see it. As we move down the group, the principal quantum number increases. A new energy cell is added at each succeeding element. What do you mean by this line? If I talk about group number 1, so elements of group number 1 are hydrogen. What is the atomic number for hydrogen? It is 1. Then lithium 3. Then sodium 11. Then potassium 19, and so on. So what will happen, student? You can see. Here, 1 electron we can fill in K shell. So here, electron will be filled in K shell, because in K shell we can fill maximum 2 electrons. Then here, in K we can fill maximum 2 electrons, but we have 3 electrons here. So 1 electron will move to the next energy level. Okay. Then here 2, 8, 1. And here 2, 8, 8, 1. So in case of hydrogen, only one cell is here. But in case of hydrogen, only one shell is here. But in case of the lithium, there are two shells, K shell and L shell. There are two shells. And in case of sodium, there are 3 shells. And then in potassium, there are 4 shells. Means when we are moving down the group from top to bottom, then number of cells are going to increases. Number of cells are increases. If number of cells will increases, then atomic size also increases. First reason is that this is clear to you or not? Yes. Second one, if I write configuration in form of the subshell, means for hydrogen it is 1s1. For lithium it is 1s2, 2s1. For sodium it is 1s2, 2s2, 2p6, then 3s1. So student, you can see here value of n is increases. Here n is 1. In case of lithium, n is 2. In case of sodium, n is 3. Means, and n, what is n? N is the principal quantum number. And principal quantum number tells about the energy of the shell. Okay. So here, value of n is going to increase when we move from top to bottom, when we move down the group. Because value of n is going to increase, so size of atom is also going to increase. It is clear to you or not? Okay. For example, if we draw structure, so in hydrogen, this is nucleus. 1 electron we can fill only in K shell. But in case of lithium, this is nucleus, 2 electrons. Two electrons are filled in one shell and 1 electron is filled in next shell, in L shell. If I talk about sodium, then there will be 3 shells. Two electrons are in K shell, 8 electrons in L shell and 1 electron in M shell. Means this is the size. This is the size. Center of nucleus and outermost shell. Distance between them. It is known as the atomic radius. Atomic radius. And if atomic radius increases, then atomic size also increases. Means atomic size and atomic radius are directly proportional to each other. So here number of shells increases. There are 2 shells. So atomic radius is also increases. Here again number of shells are increases, so atomic radius is again increasing. Okay, so down the group atomic radius increases. Why it increases? Because down the group number of cells increases and value of n, value of principal quantum number also increases. It is clear to you or not? Yes. As we move from left to right in a period, the nuclear charge increases. Nuclear charge increases by 1 unit in each succeeding element, while number of shells remains the same. This enhanced nuclear charge pulls the electron of all shells closer to the nucleus. This makes each individual cell smaller and smaller. This results in a decrease in atomic radius as we move from left to right in a period. What do you mean by this? If I talk about period 2, so there are the elements: lithium, beryllium, then boron, carbon, nitrogen, oxygen, fluorine, neon. Fluorine, neon. Now write down configuration for that. Here atomic number is 3. Here atomic number 4, 5, 6, 7, 8, 9 and 10. Here configuration is 2, 1, 2, 2, 2, 3. Because in L shell we can fill maximum 8 electrons. We can fill maximum 8 electrons. So here you can see in all elements, number of cells are same. Here also 2, and in case of beryllium there are also 2 shells. Means number of cells are not increasing here. Here number of cells are same in all elements. But here nuclear charge is increases. Here number of cells are same. But nuclear charge, effective nuclear charge, is increases. Here it has only 3 electrons. It has only 3 electrons means number of protons will also be 3 here. Okay. And here there are 4 protons. Okay. So charge on nucleus. Because here electrons are increases, so number of protons are also increases when we move from left to right. Okay. So what will happen? Then there are more positive charge on the nucleus. So nucleus has more tendency to attract the electron towards itself. Because it has more tendency to attract the electron towards itself, then what will be the effect on the atomic size? Because here attraction is more, so size will goes to decrease. Okay. So in period, number of cells are same, but effective nuclear charge means the charge on nucleus which is attracting the electrons towards itself. That is known as the effective nuclear charge. So when we move from left to right, then effective nuclear charge increases. So it has more tendency to attract the electrons towards itself. So atomic size will goes to decreases. So students, in group from top to bottom, size increases. Why it is increases? Because number of cell increases. Value of principal quantum number increases. But in period when we move from left to right, then atomic size decreases. Why it decreases? Because the effective nuclear charge increases. Then the atomic radius increases as we move from halogen to the inert gas. This is because inert gases have completely filled orbital, hence the interelectronic is maximum. We express the atomic size in terms of van der Waals radius since they do not form covalent bonds. Van der Waals atomic radius is larger than the covalent radius. Therefore, atomic size of inert gas in a period is much higher than that of the preceding halogen. What do you mean by this? I have already told you that when we move from left to right, then atomic size decreases. Why it is decreases? Because nuclear charge increases. But halogens are the elements of the group number 17. And inert gases or noble gases, these are the elements of group number 18. And they exist, inert gases exist in right of the halogens. After that, size of inert gases is greater. Size of inert gases is greater than the size of the halogens. Why it is? Because they do not form covalent bond. Inert gases do not form covalent bond. They form van der Waals force. They have van der Waals force of attraction only, and van der Waals force of attraction has more bond length as compared to the covalent. It is clear to you or not? So here, why they have van der Waals force of attraction? Because here completely filled orbitals exist, because inert gas have their completely filled orbitals. For example, if I talk about neon, so neon is atomic number 10. So here 1s2, 2s2, 2p6. P orbitals can fill maximum 6 electrons, and already 6 electrons are here. So it has completely filled p orbitals. Okay, and if I want to fill electron in shells, so here 2, 8. And according to octet rule, its octet is also completed. Okay, so they cannot form covalent bond with other element because they are already stable. They have their completed filled octet. Okay, they have completed filled orbitals. So they do not have tendency to form bond with other elements. Okay, so they can attract with each other only by the van der Waals force of the attraction, and extent of the van der Waals force of attraction is smaller than the covalent bond. Means if this attraction is smaller, then size will be increases. So size of the noble gases are greater than as compared to the halogens. This is the exception. It is clear to you or not? Yes. Yes, students, if we talk about the ionic radius, Ionic radius. Ionic radius means if an atom either lose the electrons or gain the electrons, then it convert into the ions. If element lose the electrons, then it will attain positive charge on this, and it is known as cation. It is known as the cation. And if element gain the electron, then it will attain negative charge, and it is known as the anion. Anion. Always size of anion for an element will be greatest as compared to the size of isolated atom, and it will be greater as compared to the size of cation. For example, if it is asked to us that arrange the iodine plus and iodine negative, means anion form, in increasing order of size. So how can you arrange? Here you can see this iodine, it is in an ionic form. Okay, so size of this will be greatest. Size of this will be the greatest in between these three. Then size of atom, iodine, and then size of the cation, I positive, will be the smallest. Why it is? Okay, because here one electron is going to be removed, but number of protons are the same. So number of protons increases as compared to the electrons. So they can hold the electrons towards itself by a greater force of attraction. Okay, so their size will goes to the decreases. But in case of the anion, it is gaining one more electron. So here number of electron increases, but protons are same. So number of proton decreases as compared to the number of the electrons. So it is not easy to maintain the electrons, to attract the electrons towards itself tightly. So what will happen? Then they are loosely bound, means atomic size decreases, then size will goes to increases, then size goes to the increases. Hence size of anion will be the greatest, then size of atom, and then size of the cation. Okay, and if I talk about the isoelectronic species, isoelectronic species. What do you mean by the isoelectronic species? Isoelectronic species are those which have same number of the electrons. For example, if we have aluminium 3+, magnesium 2+, sodium plus, neon, we have fluorine negative, oxygen 2 negative, nitrogen 3 negative. All of these have 10 electrons. Here aluminium has atomic number 13. It has lost 3 electrons, so there are total 10 electron. Again here also 10 electron. In case of this, there are also 10. Means all have 10 electrons. All have 10 electrons. So how can we arrange them? In according to their size. Okay. So here anion will have the greatest size, and which have more negative charge on it, it will have the greatest size. Okay, so here these are the anions, and it has 3 negative charge on this, so size of this will be the greatest. Then O2 negative, then fluorine, then size of the element, and then size of the cations. If charge increases, positive charge increases, then size goes to decreases. Size goes to decreases. It is clear to you or not, students? If it is asked to you that which one is the larger between sodium, magnesium, aluminium, okay, so how can you tell? You know, you will see the position. You will see the position of these elements in periodic table. So here you can see, this is sodium, this is magnesium, and this one is the aluminium. Okay, so you can see all lies in the same period. And when you know very well, when we move from left to right in a period, so what will happen? Atomic size decreases. Atomic size decreases. So atomic size of the sodium is greatest here, then size of magnesium, and then size of aluminium. In this way, you can give the answers. Okay. If it is asked to you that what is the size order in sodium, potassium, magnesium, then you have rubidium. So how can you tell? You will see the position. You will see the position again. So here sodium, this one is potassium, this one is magnesium, and this one is the rubidium. First thing you know very well, if we move down, then size increases. So here it has greatest size. Rubidium has greatest size. Okay. Then after rubidium, potassium. Okay. And in between these, you know, when we move left to right, then size will goes to decrease. So what will be the order of the size? Here order of size will be the rubidium, then potassium, sodium, and then magnesium. So this will be the order of the size. Clear to you or not? Any doubt in this topic? Okay. So thank you. Have a nice day.